Welcome to today's lesson on Newton's second law of motion, one of the most important principles in physics. This law explains how the force applied to an object, its mass, and the resulting acceleration are all connected. By the end of this lesson, you'll see how this simple equation, F equals ma, helps us understand and predict motion in the world around us. Let's break this down. If you have a constant force being applied, meaning the force isn't changing, the relationship between mass and acceleration becomes clear. For example, if you apply the same force to two different objects, one heavier than the other, you will observe that the heavier object accelerates less. This is because with the same force, a larger mass resists acceleration more due to its greater inertia, a property of matter that describes an object's resistance to changes in motion. Practice problem number 1. Mass impact. Can you explain how the acceleration of an object changes when its mass is doubled while the force applied to it remains constant?
Okay, if the mass is doubled and the force stays the same, then the acceleration also will double.
Not quite. Doubling the mass does not double the acceleration if the force stays the same. How does Newton's second law relate acceleration, force, and mass?
I can't remember actually. Can you help me with that?
Sure. Newton's second law says acceleration equals force divided by mass. What happens to acceleration if the mass increases but the force stays the same?
Oh, right. Okay, so force equals mass times acceleration, right?
Yes, that's right. Force equals mass times acceleration.